Hello students, I am here with a very important question for your exam of fluid mechanics and hydraulic structure. That is, derive Euler equation of motion, state assumptions in Euler equation. You can see that this question is frequently asked in many exams like May 19, May 28, May 2018, December 2018, January 2017. Okay, let's start. We know that the Euler considered the gravitational and pressure force for the derivation of Euler equation. So we can write as total force is the summation of gravitational force Fg and pressure force Fp. For derivation of Euler equation, here we consider a stream tube having a length ds and cross sectional area dA. Now what is stream tube? That is discussed, we have discussed in previous lecture. So if flow takes place, then the pressure, some amount of pressure will be acting at that inlet point. So we can write as a in terms of force. So we have to multiply that pressure intensity with the area of a stream tube. So we can say that at inlet point 1, the total acting force will be P into dA. Now the force is acting at inlet point. Some amount of reaction force will also generated at the outlet, that is some amount more than the at point inlet. So the resisting force will be in opposite direction, that is P plus del P by del S into ds into dA. Okay, that is about pressure force. Now if we talk about gravity force, then gravity force will be due to the weight of the stream tube or weight of the element. So for weight, we have to multiply the density with the volume, and that is written as W equal to rho g into dA into ds, that is density, and multiplied by gravitational force into dA into ds, that is area and the length of the stream tube. Okay, so here we get all the forces acting on the stream tube, that is pressure force and gravitational force. Now we know that the gravitational force will be acting in downward direction, that is inclined with the flow line. Okay, so here you can see that the gravity force in downward direction denoted by dz, and the force inclined, stream tube is inclined at theta angle. Okay, so we can say that in between ds and dz, that is stream tube and gravitational force के बीच में थीटा एंगल बना रहा है. So we also know that the force equal to mass into acceleration. Okay, so here two forces are acting. So we take the algebraic sum of that. First P dA, that is positive, minus P plus del P by del S into ds into dA, that is resisting force, that is negative, which is in opposite direction. So we take it negative, minus rho g dA into ds, that is the weight, and the weight is acting downward. So two components are there due to the inclination of stream tube. So here we consider rho g dA into ds cos theta, that is negative, that is also in the opposite direction. So that is the force component. The algebraic sum of force is equal to mass into acceleration, m into as. Now here we can write mass equal to density into volume. Okay, rho equal to m by v. So we have to write down in terms of mass. We can write as rho into density into volume. So rho into dA into ds, m equal to rho into dA into ds into acceleration. Okay, so this equation will be p into dA minus p plus del p by del s into ds into dA minus rho g dA ds cos theta equal to rho dA ds into as. Okay, now acceleration. Acceleration, as we know that acceleration equal to dv by dt. Okay, now here if we have to write the velocity in the function of space and time, so we can write as acceleration equal to del v by del s into ds by dt plus del v by del t. Okay, so here ds by dt will be written as velocity component, so we can write as v into del v by del s plus del v by del t. Here we consider a steady flow, so that's why del v by del t equal to 0. What is the definition of steady flow? That is, the flow properties with respect to time will be constant, that is not changing with respect to time. So we can say that del v by del t equal to 0. So acceleration will be written as v into del v by del s. Okay, so substituting the value of acceleration in the equation will be minus del p by del s into ds into dA minus rho g dA ds cos theta equal to rho dA ds v del v by del s. Okay, so now we have to divide the whole equation with rho into dA ds. Okay, so after dividing the whole equation with rho dA ds, the equation will be minus del p by rho ds minus g cos theta equal to v del v by del s. Okay, now here we can see that the cos theta is shown separately. Theta is the angle between the length component, that is ds, and the gravitational force which is acting in the downward direction. The theta if from this figure B, if we have to write the value of the cos theta, so we can write down as a cos theta equal to dz by ds. Okay, so here cos theta equal to dz by ds. So value of cos theta is again substituting in this equation. The equation will be 1 by rho del p by del s plus g dz ds plus v del v by del v del s equal to 0. The above equation is known as the Euler's equation of motion. Okay, the motion Euler equation will be 1 by rho del p by del s plus g dz ds plus v del v by del s equal to 0. Okay, thank you.